Hi, welcome to 3.5 Design Challenge 3, the Quadrilateral game. All right, today we're going to talk about symmetry to help us work the quadrilateral game that we'll play in class as well as part of your assignment for 3.5. So let's start with a couple definitions. First of all, reflective symmetry. The definition is a shape with reflection symmetry has two halves that are mirror images of each other. So as you can tell in the examples that we have here, we have a circle. If we put it exactly in half, it's reflective. A pentagon, a triangle, a heart, and different types of quadrilaterals. Now, to get this reflective symmetry that we're talking about, there is what we call a line of symmetry, okay? It's an imaginary line where you can fold a shape and have both of the shapes match up exactly. So here's lots of examples here. The first one over here that I wanted to point out has no lines of symmetry, and you can tell why it doesn't is because it doesn't look the same on both sides. All right, here is a pentagon that has one line of symmetry. If we fold this shape in half, it's going to be symmetrical. Okay, now what's cool about a circle is that we could fold it lots and lots of different ways, and a circle is known to have an infinite number of lines of symmetry. All right, an equilateral triangle, here's an example down here, a square. A parallelogram now has no lines of symmetry, however, because if we fold it in any direction, it's not going to line up. This flower is an awesome example of different ways we could fold it and we'd still have symmetry. Okay, I thought what we could do right now is go ahead and look at this triangle, all right? And I wanted to demonstrate really quickly what I mean by lines of symmetry. So I've taken a triangle here and I'm going to fold it like this. And as you can see, it goes right over itself. So there's a line of symmetry, okay? All right, I'm going to fold it now over this way. All right, again, right over itself. There's another line of symmetry, okay? And the last way I'm going to do it is I'm going to fold it up, okay? And again, as you can see, line of symmetry. So we would say, in this case, that the triangle has 1, 2, and 3 lines of symmetry. Okay. Now, in real life, people use reflective symmetry. You typically refer to something being symmetrical. Here's two great examples in architecture of symmetry: the Eiffel Tower in Paris and the Taj Mahal. Okay, awesome examples of symmetry in real life. However, if something is not symmetrical, we call it asymmetrical. And as you can tell from this example, symmetrical, not symmetrical. All right? Okay, now in math, we all talk about rotational symmetry. Okay, that's when a shape has rotation symmetry if it can be rotated less than, and this is really important here, less than a full turn, because everything would have symmetry if we just rotated it a full circle. Okay, so it has rotational symmetry when we can rotate it less than a full turn and it looks exactly as it did before we rotated it. All right, so typically we rotate it from its center point and then we rotate. All right, now this is awesome because you can see from this example of the division sign and the multiplication sign, because they've colored in the spots so you can see what happens when it rotates. This was rotated 180 degrees and it's still symmetrical. So this has rotational symmetry. Okay, now let's look at the multiplication sign and watch the dot. We move it a quarter of a turn or 90 degrees and it's still symmetrical. We rotate it 180 degrees and it's still symmetrical. And we rotate it 270 degrees and it's still symmetrical. One more thing I want to go over just to help you with the problems that you have throughout this game is area. Area is something that you've been doing since 5th grade, and I'm hoping that it is just a review for you. So area of a triangle is 1/2 times base times height. All right, so that means we're going to multiply 1/2 times the base, which is the bottom part of the triangle, okay, and we're going to multiply that number times the height. All right, and then we have the area of the triangle, and depending on the unit that we're using, area will always be squared because we're taking 2 dimensions, the height and the base. So 2 dimensions we're multiplying together, that gives us area is always squared. All right, quadrilateral. It doesn't matter whether it's a square, a parallelogram, trapezoid, okay? We're going to always do it base times height. Now, as you can tell, if we have something that's not like a triangle or not like not like a square or not like a rectangle, we need to make sure that we draw a baseline down here and take, here's the base, and then we take the height here. Okay, and that gives us the area. I'm hoping again these things are a review for you. If they're not, will you please make sure that you come visit me and we'll go over area together. All right, I think you have what you need. Good luck.